And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining a solution of every problem of Lead Code and Geeks for Geeks within less than 5 minutes. Okay, so today's problem of the day is peak element, which is a medium level problem. So let's find out what we will be given into this problem and what we have to do. So we will be given two params into this. First one will be an array of integer type and second one will be the n, which will be the length of that array. Okay, and array elements will be from 1 to 10 raised to the power 6. Okay, all right, and the array size can be from 1 to 10 raised to the power 5. It means we cannot have any square time complexity. Okay, so let's find out what we have to do. So we will be given some numbers like 1 2 3, or it can be anything like 3 4 2, and we have to tell the number which is the highest one. Okay, so that's the thing, that is the thing, we have to return the highest number. But the thing is, there are few conditions. The first condition is that if we have to return the peak element, in other words we have to return the peak element, and peak element will be that such that its value is greater than the value of its adjacent elements. Okay, the value of it is greater than the value of its adjacent elements. Okay, all right, so means something like 3 4 2. Okay, in here you can see that the value of 4 is greater than its adjacent element. Okay, in this way. So I've written something for you, notes. So let's jump onto the notes section, because the thing is we can simply find the highest number in big O of n time complexity, but we have to solve it in and we have to solve it in log n time complexity. So let's find out how we will be solving that. Let's jump onto the notes section. Okay, let's find out what will be the pattern of the array. So there will not be any random elements present into the array. There is a fixed pattern for that. Pattern will be something like at a particular till a particular range, the elements will only increase, and after that the elements will only decrease. Okay, so here let's suppose this is an ideal case which can be present in our array. Okay, which can be an array. So here you will see that the elements are constantly increasing, and after that they are decreasing. Okay, so if you will plot it into the array, it will be something map. It will be something like 1 2 3 5 3 2. Okay, something like this. So here you can see the peak. Now this is the peak and you have to return this index. This index is what? 0 1 2 3 3. So you have to return 3. Okay, in this way you have to do. Now the case is like there cannot be any array such that there are two peaks. Suppose there are two peaks, so it cannot be possible in this test case. This test case cannot be possible. So at every time we will be either increasing till one point and then we will be decreasing. Okay, so we will always get one peak and we have to return that index. Okay, I think the problem statement now will be very clear, and there can be few edge cases as well. Like suppose we are only increasing, but we are not decreasing. Okay, we are not decreasing at all. We are not decreasing. And similarly, there can be case when we have only decreasing, something like let's say 4 3 1. So in that case you will return 4. You will return 4 because it's the maximum one we have to return. So there is no downfall, it's okay, but there is a peak, there is still a peak. Okay, so you have to return that. Okay, so the edge case is clear, the question statement is clear. Let's jump on to how we are going to solve this. So we can quickly find out. Look, we have to solve this in log n time complexity, because we can use binary search here. Okay, so binary search basically means we can divide it. We can divide the problem such that we can discard one half of the data set at every point. Okay, so suppose I got the middle. I got the middle of number. Okay, so the middle array will be this 3. Okay, so I will check middle with its previous one if it is there. Okay, I will check middle with its previous one if it is there. So 2 and then 3. 2 and then 3. So 2 is less than 3. It means what? It means we are still climbing. We are still climbing. Okay, and okay, all right. So we will find out first, and first of all, when after finding middle, I will check if its a left side is less than it, and if it is like, we have to find out if it is greater than the adjacent element. If it is greater than the adjacent element, yes, we will simply return that. Okay, so no, this is not greater than its adjacent element because there is 5. Okay, after that I will check that 2 is less than 3. Okay, so in that case we are increasing. So our peak element will be on the right side. Our peak element will be on the right side. So I will do something like low is equal to high minus high, middle plus 1, low equal to middle plus 1. So now this is our array 5 3 2. Okay, again I will find out my middle. So middle is 3. Now again I will check if it is greater than its adjacent element. No, it is not greater than adjacent element. Okay, now again I will check if 5 is less than 3 or greater than 3. So I will check 5 is greater than 3. Middle minus 1 is greater than middle. Okay, so in that case we will say that our peak element will be in the left side. So I will do something like high equal to middle minus 1. Now I've got only one element, that is 5. So we'll simply return that. Okay, that's simple, very simple. I think the problem statement will be clear, the approach will be clear, code will also be clear. Now let's jump onto the code section. But before that, if the problem statement is clear, if you have loved the solution, please don't forget to subscribe the channel. Okay, let's see the code of it. Okay, all right. So its code is going to be a proper binary search solution. I think everyone know what it is. So simply we will having two variables, starting, let's say, or let's say, yeah, starting equal to 0 and end equal to n minus 1, because n is the length. Okay, and after that we will simply do while str is less than equal to int, and we will check. We will first of all find out mid. Int mid equal to str plus end by 2. Okay, after that I will check if what I told, if ARR of mid minus 1 is less than or equal to ARR of mid, and then ARR of mid plus 1 is also less than or equal to ARR of mid. In that case, I've got such that our it's greater than or equal to our adjacent elements. So I think we have got our answer and we will simply return mid. Okay, very simple, very simple. After that, what I told, if ARR of mid is greater than ARR of mid plus 1, in that case, what we will do, ARR mid is greater than ARR mid plus 1. It means our peak element will be in the left side. So we have what we will do on the left side. We will simply do int equal to mid minus 1. Otherwise we will do simply starting equal to mid plus 1. Okay, very simple. And here after that I will simply return, we will return anything, let's say 0. Okay, because we will be covering all these cases here, but there is, but we, as you know, we have discussed some edge cases as well. What if there are only increasing or there are only decreasing? Okay, so to that, look, this condition we will be having one OR here, that is mid equal to 0 or. Okay, so in that case, if mid equal to 0, so then this condition will, we cannot find. If mid equal to 0, mid minus 1 will be out of bound. Okay, to recover that, and here mid plus 1. So if mid equal to n minus 1, in that case we cannot have. So mid equal to n minus 1 or. Okay, so either of these conditions is will be true, we will simply return mid. Otherwise, I think it should run now. It's very simple code. I break down into smaller problems so that it doesn't trouble you as well. Let's quickly find out. Okay, it's giving some error. Let's quickly check that. Oh, okay. I have forgot this equal to here. So it should be something like this. Now let's try to submit it because it's a binary case. So when we are taking str and n minus 1, so there can be one point where there is only one element. Okay, so that time we have to return that. Okay, all right. So it's getting accepted as well, and I've got my Geekbit. So thanks everyone. I hope everyone should have enjoyed the explanation as well. Please subscribe the channel and please hit the like button. Please share your feedback into the comment, and I'm going to see you again tomorrow because I will be now regular on this channel. Okay, thanks everyone. Bye.